Go ahead and start the recording. All right, cool. We're recording. All right, folks, welcome to part one of Shark on the Wire series in Technicolor. And guys, before we dive in, can anybody, just give me their, their thoughts and their definition of what Wireshark is? Anybody? I mean, doesn't have to be right or wrong or anything. Just what you guys think it is.
Can you hear me?
Yep, we can hear you.
I have a basic understanding of Wireshark is just to analyze the traffic within the network to see if there's been an attack or if something's wrong with the network. Just a high level overview.
No, Jose, that's dope. That's exactly a high level at least what it is. Anybody else? Anybody have thoughts of what Wireshark is or how to use it?
Now it really analyzes the traffic granularly to the acknowledgement packets, the sessions. You can really see in depth all types of metadata, where the source and destination is coming from, DNS requests. Any type of data or packet that's going across the wire, you can analyze it for deep inspection.
Cool. Okay, perfect. All right, but folks, exactly what Jose and Hakeem said. Basically, it's a tool to promiscuously look at packets that are traveling on a wire, traveling throughout a network. Okay, powerful tool to analyze. Basically for you to see the flow of traffic within your network. It's funny, you guys were talking about the cloud, and I got a buddy who's a cloud network engineer, and they still have to work with Wireshark because they have to analyze all the requests that are coming in from their remote sites, their customers, what have you. So very good tool to understand and know how to use, even though all companies, applications or resources are shifting over to the cloud. Okay, so like any other tool, right? As long as you know how to use it, you can make it, work for you, for an advantage, right? But if you don't know how to use it, then it's going to look intimidating, right? So we have a couple of fields. You guys see this, the packets being captured. We're going to go ahead and start off slow. First things first, we have our icons, right? I'm sure you guys saw the Wireshark cheat sheet. I had that from a few years ago. Hopefully it works. Of course, we have this. Shark fintail, that means to go ahead and start a capture, right? Typically when you guys are in the field, and that'll be in part 4 or 5, me and Claude will go over how to, plug it into a network device and actually capture packets, set up a span. But typically you would go ahead and as long as you enable, capturing packets on your PC, you being that network engineer, you go ahead and click that Shark fintail, it'll go ahead and start capturing packets.
David,
and of course, yes.
I'm sorry. Can you have like others? Oh, perfect. Okay, it was just noisy in the background.
It was noisy. Oh, okay.
Yeah,
okay,
not your background.
Oh, okay, cool. No,
okay.
Thank you. All right. So, man, where did I leave off? Yeah, okay. I left off on the I think the stop button. So we have the stop button, and again, guys, I'm going slow, and feel free to stop me at any point. We have the stop button. Very important tool to understand and button to understand, why you need to know where it is and how it works. You guys have PCs, right? And you have a NIC card, right? That NIC card, it only can go ahead and process so much information at a certain time because it's a gig card, it's a gig NIC interface, right? So if you, for example, right, let's say, and again, this will make sense in part 3 or part 4. Let's say you're doing a span, right, on your switch or your network device for all your VLANs on your switch, right, to your PC, and you have almost 70 users in that VLAN, and they're all working from 8 to 9 o'clock, sending emails on the computer, on YouTube, or what have you. Imagine if all that traffic from that VLAN is going to replicate into your laptop. Your laptop is going to crash. Probably break your NIC card. Seen it before. So, you know, typically whenever you're analyzing anything and analyzing packets or what have you, you typically want to go ahead and just capture it, quick second, go ahead and stop it. You know, it travels at, you know, almost close to, you know, a millisecond. So you guys shouldn't need to capture a whole bunch of, you know, packets for more than 60 seconds. Okay. So very, very good thing to learn. This right here. Who should I pick on? Hakeem, what do you think that icon does?
Refreshes the capture.
Absolutely. Absolutely. So all that does, right? If we know that the shark fintail, and again, I'm gonna keep it simple. If the shark fintail starts the capture, that with the, you know, the Uno, you know, reverse thing, it just restarts it or refreshes in Hakeem's mind. Simple as that. Just refreshes the capture. Okay. Right here. And typically, in everything that you guys see grayed out, we have to go ahead and we would have to set that up prior to us, you know, starting our Wireshark capture. But what I have highlighted now is Wireshark capture options. This is where, for example, right, if we want to capture specific traffic, we want to manipulate the capture, this is where we will set those settings. And we're going to do that. And again, probably, you know, part 2 or part 3, we're definitely going to do that whenever we start to investigate traffic between routing protocols or traffic between servers and the cloud, or et cetera. So we'll take a look at that. Of course, we can go ahead and use this. Instead of going to file, we can use this to go ahead and open up a pre-existing Wireshark capture that we have. This, of course, tells us we can go ahead and save a current Wireshark capture. This right here. In Wireshark, I believe with the new update, you're able to open multiple Wireshark captures and analyze it, right? Because you may not, you know, you may have already gotten your capture and you may save it to your laptop. You may want to look at a few captures to analyze, hey, I see traffic that's going from, you know, one device to one device. Let me check the traffic that's compare it to traffic that's going from one device to another device. So this is where this would come in handy. Okay. So if you don't want to look at that traffic no more, or that Wireshark capture, you can go ahead and close it. Okay. Of course, we have the reload the Wireshark capture button just in case you get stuck or it stops responding. You can always go ahead and reload it. And of course, and we'll take a look at this one. I'll show you guys how this works. But this is basically a search button. You can go ahead and search for individual packets if need be within Wireshark. Okay. So let's say, you know, depending on any of these criteria, and of course, we're going to touch on that soon. If we want to check on, hey, let's search for the MAC address of this, or let's search for protocols for spanning tree, right? Or for STP or what have you. You can use that magnifying glass to search just for that, right? And there's plenty of different other ways to go ahead and search within Wireshark, but you know, again, it's all about knowing how the tool works so that you can, you know, use it as an advantage for you to analyze packets. That's the whole scheme of the game. Okay. What's next? Okay. Next, let's say, you know, we stop the capture, right? Let me hop out of here, show you guys in real time. If I wanted to go to a previous capture, it helps me navigate to different packets. Okay. So let's say, hey, okay. The destination is this MAC address, source is that MAC address. I can just compare it if I want to look at 2 different packets. Okay. So
these are different frames, right? So
did somebody just ask a question? It just was in and out.
it's Ramsey. I was just saying these are different frames.
Yes. These are different frames, packets, what have you, layer 2, layer 3, what have you. It's capturing the whole packet. So yeah, these are different packets that Wireshark was able to capture.
Thank you for that.
No biggie. Good question. Again, we have this right here. Let me pull back up my annotation tool. Where is it? There we go. All right. Yep, there we go. So again, this goes up to the previous packet. This goes forward to the next packet. This actually stops the current active capture. So let's say, for example, Angela and Patrick are working on, trying to figure out, hey, for PCs that are in VLAN 25, we need to see those, these PCs that send DHCP traffic, send that first packet, the DHCP discover packet. We want to see how that looks like, right? So let's say they're just having the packet capture run. A lot of packets. If Angela or what have you, or Patrick sees that packet, they can go ahead and stop it with that button. Say, hey, this is what I'm looking for. Let's investigate this. So that's what you can use that button for. And there's plenty of other ways you can use that button. We'll touch on that definitely in part 4, because that's when we're going to go in depth, and we're going to do some modules, and Carlos, Joe, and Brian and Angela, and definitely Ramsey and Calvin. Sorry, Calvin. I'm volunteering you. We're going to jump in and start analyzing packets. Okay. But everybody's going to get a chance to analyze packets. Okay. This right here, of course, restarts an active capture session. And guys, I'm sure you guys are picking up now that, hey, there's a couple of other buttons that do the same thing. This is exactly what it is. Most buttons repeat themselves. You just have to know how they work effectively within Wireshark to make it work for your advantage, okay? So with that being said, I'm gonna take a pause here. Does all of this make sense so far? Anybody lost? Anybody, confused?
No, I'm good. I understand.
You good? Okay, okay. Anybody else? All good? I'll take the silence as a, keep going.
But I just want to clarify one thing, if that's what I think.
Okay.
Okay.
Sure.
You
Balance and simplicity.
okay, so you were saying that we could compare one capture to the next or another capture. So I'm thinking, is it it is possible that with the Wireshark we could use it as a way to make baselines for our network?
Absolutely. That's an excellent question. Yes. And that's typically what, and Claude and Carlos, I know you guys can comment on this as well, but whenever you're implementing, any security measures, and Brian can, comment on as well. Whenever you're implementing security measures or protocols, what have you, you're first setting up your network, you need to understand the bandwidth. You need to understand the flow of traffic. Wireshark, you'll go ahead, pop that bad boy in your network. You go ahead and mirror that traffic to a port, hook up a PC or a server to it, however you want to do it. Watch that traffic. See how it looks on a 30-second interval or a 60-second interval, how that traffic looks at peak times. So you can go ahead and get that baseline. So then from there, right, and speaking forward, we can go ahead and say, all right, let's plan for getting this type of firewall that can handle, 10 gigs, right, or 20 gigs, right? So we can see how much of traffic is being pushed on an uplink on that port, what have you. So, excellent statement and question, Maxwell. Does that make sense, guys?
Sure. Yeah.
Cool. Excellent. So, again, we're still keeping it simple. We're not going too far off. Let me erase all this. Now, while I'm setting this next part up, because this is going to be a little bit interactive, can anybody explain to me the DORA process?
Ooh. That's Ramsey.
Cool. What's the DORA process?
Discover, offer, request, and acknowledge.
What does that mean?
Right. So DHCP, when a client needs IP address with a subnet mask, it's going to reach out to the DHCP server.
Okay. And then what happens?
It's going to send a discover packet broadcast, and the DHCP server is going to see it and respond. And the client will, so that'll be an offer from the server. And then the client will reply as a request. Sorry, do you want me to keep going?
No, that's perfect. Great job.
Okay.
Great job. At a high level, that's perfect. Jose, you got something? I'm sorry.
No, it's fine. I got it. Thank you.
Okay, perfect. So what we're gonna do, we're gonna go ahead and do this. Give me 1 second. We're gonna actively see packets flowing from a PC that doesn't have an IP address flow throughout the network and analyze it via Wireshark. Okay? Give me one moment. Let me go ahead and pull this up.
This is exciting.
It's like a cake coming out of the oven. It's like, ooh.
Let the packets fly.
Thank you. Goofy. Okay. Perfect. And guys, we're going to look at a couple captures, okay? So if it doesn't make sense now, it's perfectly fine. We're going to touch on it soon, and we're keeping the same topology that I'm about to show you. But as you guys can see on my screen, this PC should not have an IP address, okay? I want everybody to take note of that MAC address though, because Angela is going to be the first person to analyze some packets for that MAC address. Hi, Angela.
Is she back? And the chat says,
I literally just got back.
okay.
I literally just got back, and all I heard was Angela is going to analyze that. Okay.
We felt you.
Yeah, exactly.
It's all good. You guys have a few minutes, so guys, take a break while I'm setting all these captures up. You guys can go ahead and talk amongst yourselves, or ask me, or Claude, or Carlos, or anybody some questions about captures while I set this up for you. Okay.
I'm curious if we got any like security people in the house, like what are the applications for Wireshark? Like how could y'all use it?
That's a good question.
Okay, so can you hear me?
Yeah, Claude, we're good.
Absolutely.
Yes. So in that sense, when I was talking with David, we were talking about this here Wireshark presentation. I actually gave him some previous captures where I was sending messages back and forth between my Cisco ISR routers in plain text. Now you can actually sniff those packets and dig down into it and actually see the actual message itself and read what it was actually saying, what I was actually saying to myself through the VTY lines. So from a security standpoint, think about that. I also did another one where I didn't give it to you, Dave. I think I got that on Facebook somewhere from a long time ago. I actually snagged a password, the actual password from one router to another router. You know, stuff like that. You can, if the security is not in place, Wireshark will pick that stuff up. And if you dig hard enough, and if you know where you're digging, you can see that stuff. It's, you know, plain as day.
I also probably more curious. I understand that about like security using it on like an offensive side, like on the blue side, like not reacting. Like how could that work? Like could it be used to help implement policies some type of way, or?
That would be defensive, right? Like what he was saying is like, offensive, like you're sneaking stuff. So defensively would be, you're getting a lot of traffic all of a sudden, it's all hitting port 80. And so you'd want to see, where is this traffic coming from? And I think there's a lot of case studies about that. Is that what you're talking about?
No, not really. I don't know if it's a thing or not. I'm really talking
Okay.
about like, let's say I'm in security, and I'm just like thinking of ways of like how people could like attack a certain vector or something like that.
Yeah.
So
You'll
like
see.
how could you like creatively think and use Wireshark to, I don't know, implement policy or something like that? I don't even know if that's a thing. I was just thinking.
No, Hakeem, and that's a valid question, and we'll be sure to go ahead and touch on that in part 4 and part 5, because that's, we're going to get into deep packet analysis using Wireshark and see how, again, from a base level of security, how attackers or bad actors can go ahead and take a look at your packets and, for example, investigate and see, oh, I can capture packets within this specific VLAN and understand who's the DNS server for Kelvin's department, and do a DDoS attack and shut his network down for a few moments. So that's how people can use Wireshark to an advantage. One piece of it. Does that make sense?
Yep.
Cool.
So David,
Cool. Yeah, Jose, what's going on?
Do you think he's referring to like using Wireshark to hack into somebody else's computer, or to attack a network using Wireshark?
You know what? That's
Yeah,
not that. Yep, my guy.
Okay, all right, yeah.
That's one piece, right? So yeah, exactly. And again, guys, remember, let's keep it at the simplest form. And Jose, that was a perfect statement that you said. Any type of tool, a hammer, without getting too violent and too dark, a hammer, a screwdriver, right? A screwdriver can be used to put screws, to screw in screws. A hammer can be used to hammer nails, but it also can be used for something else, as we've seen in scary movies and terror movies. It's all about how you use it, right? So, you got your good actors, you got your bad actors. They're going to use it as such, okay? So it's all about knowing the fundamentals of how that tool works. Then you can manipulate it as such. Does that help out, Hakeem?
Yeah, that was dope, and he put it in perfect words, kind of, sort of. Because if I was in security, if that was my thing, I would want to know how people can use that, and how I can probably counteract that in some type of way, or set a trap or something. You know what I'm saying?
Absolutely. But and again, without getting too in the weeds, because I want to go ahead and start this module before we close out. But yeah, this is why it's not just, of course, I think I was telling Jose the Triforce of IT, without me getting too nerdy about my Legend of Zelda hobby. But yes, they're going to work all together. Security can't just manage a network. They're going to work with network folks as well. As far as network is also going to work with cloud people as well. And all of them, they have their subcategories as well. They have their different infrastructure teams or what have you. And so all of that to go ahead and make sure they protect the network, because it can't solely just be security engineers. It can't just solely be network engineers, because a network engineer, they can probably design a network, implement some configuration, but then, dude, you got you got SSH or you got Telnet enabled on all your devices. I can go ahead and grab your passwords and see what packets are passing through. So thanks a lot, buddy. So it's all about working together and understanding how tools work and how different teams work. But again, we'll get there. Part 5, we'll maybe have a part 6. We'll get there, but let's go ahead and jump in so we can start analyzing some packets and see, how it travels through the wire. Okay. So, Angela, what's up, man?
Hello. I'm nervous.
What's up, man? It's all good. No, it's all good. This is a safe place. It's always a safe place. So, we're all engineers. You guys are scientists, right? Engineers are scientists. You're meant to mess up, of course, because again, you guys are going to end up finding the answer sooner or later. Okay. So feel free to mess up, break the network. I tell you guys all day, every day. My current job, I break networks for a living. So it's all good, Angela. Okay. So
all right.
we have our MAC address. right? For our
Yes.
PC, we have PC1. We need to get an IP address, okay?
Mhm.
I'll worry about the configuration and stuff like that. I want you to write down this MAC address, okay?
Okay.
Let me know when you got it written
One
down and you're
second.
ready to go. We'll go ahead and start that process.
Okay.
And folks, because folks, after Angela goes through her part, I'm going to call on somebody else within the crowd. So be ready. It's going to be at random. Hi, Kelvin. But yeah, it's going to be at random.
Okay.
So.
Okay.
Hi,
I
Brian.
got it.
All right. So we have this, right? We have
Yes.
our MAC address. Okay. So now what I'm going to do is I'm going to force this PC to go ahead and try to get a IP address. Cool. So based on what Ramsey said, went through the door process. Let's take a look at some captures. Let's get this out the way. Where's my little eraser? There we go. Okay. So these captures are going. And so, Angela, right? We have our MAC address, right?
Yes.
Can you share with me what that MAC address is?
005079666801.
That was a bit fast. 0050.
Sorry.
It's all good.
79
Mhm.
66 68
68.
01.
And notice how it was red and then it turns green.
Yep, I'm going to touch on that in a second. Okay. Let's grab that. Copy. Oops. Put that in there's my notepad. Okay.
There's a
Guys,
lot of
can you
heads
stop
in
sharing?
here.
Guys, can you still see my screen?
Negative.
Okay, perfect.
Now we can.
Perfect. Okay. So with that, we're going to go ahead and we're going to look at the interface right here first and see if this MAC address, any package related to that MAC address that Angela took note of was captured on this interface, gigabit 0/0 on switch 2. Okay. So let's do that. So we're going to go ahead and put eth.address, which of course means the Ethernet address, okay, or the MAC address, okay? And so we're going to do equals equals. I know that looks weird, but of course that's the language of Wireshark, right? Or packet and analyst tool. Sorry guys, I have somebody jumping in the wait room. Claude, I'm going to make you host so you can mitigate people coming into the room. 1 second.
Cool.
Let me do that. There we go. Okay, perfect. So yeah, so we're gonna go ahead and put in that MAC address. 5079 66 68 01. Okay. And Jose, if you can mute yourself, buddy. Thank you, buddy. All right, excellent. So we have our MAC address that we want to go ahead and look for to see if the packet capture has found it. Okay. Angela, what do we see?
We see a few packets with that MAC address.
Perfect. Okay. All right. So let's dig into this, right? And Ramsey, you and Angela are going to work together on analyzing this right here. Okay.
Where do you see the MAC address? Sorry. Thank you.
We're gonna get we're gonna get there. We're gonna get there. But this is about knowing the tool, right? And knowing the process or what have you. So you guys are going to read your, and Claude and Carlos, keep me honest. You guys are going to read your books, right? You're going to read your CCNA books, your Network Plus books. They're going to tell you the theory, right? This is where all of this comes together, right? Ramsey just asked an excellent question. Where's the MAC address of this PC?
David?
Yes.
Will we be looking at the second part? Yes, right there where it says source and destination. Our source is, and we have our MAC address right there.
Layer 2.
Mm-hmm.
Nice.
Right. Absolutely. But let's go a little bit deeper in this, right?
Okay.
Angela, how would you know to look at that, right? What does that tell you about the DHCP process? Looking at this Wireshark capture, what can you analyze from this?
That the traffic is, I'm not sure if this is, that the traffic is coming from that MAC address.
Absolutely. Absolutely. Perfect base level analysis.
Okay.
It's coming from there. It's coming from whatever host that is. Okay. Kelvin.
Sure.
Kelvin.
Yes, sir.
Did you notate that? Did you notate that MAC address that Angela found?
I know it was, I think it was 005079666801. Correct me if I'm wrong. I was right. I wrote it.
Our system
right.
Okay. So Kelvin, I'm gonna look for that. I'm gonna look for that MAC address that you just told me about. Okay.
Okay.
On all of my captures. There's a reason why I'm doing this. And this is going back to Ramsey's question. Okay. So if we go back to the topology, right?
Right.
We captured on multiple interfaces, just like how you guys see, right? The first number corresponds to the number of the device. So switch 2, this is capture 2. Router 8, this is capture 8 on either the 0 interface or the interface 1. Same for all of them, okay? So we're capturing on multiple interfaces. With that being said, right? Kelvin, you being the engineer, why is it that if I'm searching for the MAC address of the PC on router 9, if I'm searching for the MAC address of PC1 on router 9, why isn't that popping up?
Can you show me the topology again? If you're searching for the MAC address on router 9.
Yep. Mm-hmm.
Let's see. Router 9.
Real simple.
Because it's a layer. I mean, that's a
only
layer
Kelvin. Only Kelvin, guys. Go ahead and Kelvin.
I mean, because that's a layer. Routers don't deal with layer 2. They deal with layer 3 with IP addresses.
What does that mean?
It's not going to learn the MAC address of the PC.
Keep going. Keep it simple. If you need help, let me know.
I can use a little help.
It's all good. So do routers forward broadcast?
No, they discard broadcast unless it's an IP helper address.
Perfect. So within, right, within a packet, right, does the IP address ever change, and do the MAC address ever changes?
The IP address never changes, but the MAC address, source and destination MAC address may change.
Exactamundo. Okay. So with you being the engineer, right, if we're looking at packet captures, what does that tell you? If we try to search for the MAC address of PC1, we shouldn't see it on the
shouldn't
device,
see it.
right?
Right.
We just shouldn't see it, correct?
Right, we shouldn't see it.
Or should we?
No, I mean you shouldn't. You shouldn't see it because you just said that it drops broadcast. The routers drop the broadcast, and routers don't really deal with layer 2 addresses. They only deal with IP addresses.
That looks like the MAC address for PC1 to me.
Let's see. It does.
So should we or should we not see the MAC address?
It looks like we should.
Guys, and Kelvin, great job, man. So, guys, and we're gonna close up shop here because it's coming close to that hour, and we'll stop for questions. But guys, this is just a quick preview of what you guys will be capable of in the future. Ramsey said, and I asked Ramsey that question on purpose to explain the door process. There's always a way around a way. You just have to make that way. It's not only one way to figure out what's going on in your network. Like Angela said, hey, this is, if we look at this capture here, oh yeah, that's where it's coming from, right? It's coming from PC1, right? That traffic is coming from PC1. We identified that, right? For in a Hakeem sense, hey, that's the bad actor PC that's requesting for an IP address, right? But, right, let's say we dig a little deeper, right? We're trying to investigate to see how they got the IP address. If we don't know the door process or the theory, we're going to look at this face value without clicking any of this, right? And we'll see, oh, we still don't know how it got an IP address, right? If I just put in DHCP if I just put in searching for the Ethernet address, I'm not going to find it, right? I say all that to say, as long as you guys know the theory, right? Here's where you come to Wireshark and you put that theory to practice. You start understanding, this is what's actually inside the packet. Huh. Okay, it doesn't have an IP address, the MAC address, and, right, what we learned from the CCNA, that DHCP relay agent IP address, which is the gateway, right? The gateway address for that local area network for PC1, okay? And with that being said, we'll go ahead and close this session. Any questions, guys?
Just one question on the.
Sure.
Yeah, when you asked, I can't remember his name, but like if we can see the traffic on router 9 from the PC MAC address, does that have to do something with the where is the DHCP server? If the DHCP server is, let's say, router 9, we should be able to see the traffic, right, for the MAC address from PC1, right?
Let me make sure I understand your question. And Jose, feel free to correct me if I'm wrong. You're asking me, what I asked Kelvin is that we shouldn't be able to see the MAC address of PC1 because router 9 is connected to the local area network of the DHCP server. Is that what you're saying?
Well, what you asking me if we can see the MAC address or the PC, the traffic from PC on router 9, right? On router 9, right? So let's say the DHCP server is on router 9. So we should be able to see the traffic, correct? Because it's gonna send like a DHCP request, the DORA process to router 9.
I think
right?
Sorry.
No, I got you. So hold on, Akeem. So, and Jose, please correct me. So you're asking if router 9 was acting as a DHCP server.
Yeah.
As far as the first one. Okay, perfect. So if it's acting as a DHCP server, right? If that was the case, we should see PC's one MAC address as far as traffic flow between router 9 and router 8. Is that what you're asking?
Yeah, exactly right. Yeah.
Yep. Okay, perfect. Yeah, that's incorrect.
Okay.
Because here's the thing, right? Kelvin.
Yes, sir.
What do routers separate?
You said what do routers separate? Broadcast domains.
There we go. Exactly. So Jose, so they separate broadcast domains. They separate LANs, right?
Yep.
Meaning, okay, we're not going to see anything on the LAN that. Hold on. Where's my little handy dandy tool? We're not going to see anything that's here between these guys. We're not going to see anything that's there because that's one broadcast domain in itself.
Yeah.
Nobody can communicate. Nobody can communicate unless it's R8 or R9. Now, if we had a switch between both of them, that will change, right? But they're not going to communicate. We're not going to know anything about no devices behind here, unless there's some layer 3 traffic flowing through trying to reach R9. But as far as a layer 2 standpoint, we're not going to know anything about PC1 or switch 2 for that matter. That's one broadcast domain. Routers separate broadcast domains. They separate LANs. Make sense?
Yep. Absolutely.
Perfect. Any other questions, guys?
Just want to say thank you for zeroing in on the foundation. This is really helpful.
Cool.
So that capture right there is for router 9 that we was just looking at. That you looked inside the packet and got the MAC address. So I think what it is that we can't search for the Ethernet address to figure it out. You have to look at layer 3 and then go into the packets to get the MAC address.
Good question. Hakeem, you're in the hot seat now. So DHCP operates at layer 3?
Say it again? No. Well, DHCP is yeah. Well, no. No.
Okay.
How could it be when you're looking for? Well, it has the PIPA address, which is that technically layer? Because it is an IP address. Never thought about
Anybody
it.
want to help him? Anybody want to help him of what layer does DHCP operate at?
Layer 7.
He operates on layer 3, ain't it?
It is layer 3.
Because it deals with the IP addresses.
Layer 7.
Really?
I think
Really? So it operates at layer 3. Let's think
Layer
about this,
7.
folks.
Layer 7 of DSM.
Layer 7.
Awesome. Why?
Because it's an application that
Perfect. Simple. Exactly. It's an application that's providing a resource. So it operates layer 7. Make sense, Hakeem?
Yeah, so technically is a PIPA is that as a private address, or like if it's IP anyway, because that's the address is using to communicate with the server, right?
So let me, and then we're gonna have to, and again, we'll have a separate session about that. And a PIPA address, right? It's a Microsoft standard, right? Whenever a device, right? Whenever a device can't obtain, in multiple ways, either manually or dynamically, right? Meaning automatically, an IP address from a DHCP server or statically from that computer admin, it's gonna go ahead and assign itself an IP address, which is that a PIPA, so that it can communicate with other PCs on the network that may have had a PIPA address as well, so that communication can happen. Old standard that Microsoft came up with when I was watching Rugrats and Dragon Ball Z when I was a kid. Why is it still in place? It still, helps out to this day. That's typically what a PIPA addresses are. Guys, keep me honest here. I know we have several folks that work in IT, so guys, feel free to keep me honest and let me know if I'm wrong.
Yeah.
So I will only say, so it still needs an IP address to talk to the other computer. So it's like, technically, even though it's not being routed, I guess, because it's not routable, but it's the same thing as it's a private address. No.
You're right. I'm not saying you're wrong. But let's think about it, right? Me and you being the engineer, right? So we have our network, right? Let's take a look back at the topology, right? We have our network, right? We have multiple PCs connected to it, right? PC 1's not able to get an IP address, Microsoft hands it over a PIPA address. Every other PC in my LAN has a 10.10.10.0 address. How is that a PIPA address going to help me?
It wouldn't.
It wouldn't.
So it just creates a network amongst all other PIPA addresses.
Exactly.
Okay.
Simple as that. Simple as that.
I got you. Makes sense. I love
Makes
it.
sense? Perfect. Okay. Guys, any other questions before we go ahead and close this out? All right. I'll take the silence as a hint, and I'll go ahead and close it here. All right, folks. We will see you at part 2. It'll probably be 2 weeks from now. So get ready. You guys, some people might get picked on by accident. Joe, Brian, Ramsey. Later.
Ain't no accident.
We'll be ready next time. We'll bring it to you.
All right, folks. Later.
Good session, everybody.
Good night, everyone.
Good night.
Okay. All right, good night.
See you.
All right. Thanks, Dave.
Thanks, Dave and Vlad.
No problem.
Thanks, everyone.
All right, thanks, David. Good night.
All right, boss. Later.